Okay, let's turn to the second exercise. And here we need to identify various shifters of a demand function and later of a supply function. And you see we have here a demand function or quantity demanded function, and you see the blanks. What you need to do in the blanks is either add a plus or a minus. And you see that the quantity demanded function is a function of, it's first of all the function of the demand for light bulbs. So here what we see is the demand for light bulbs. So that's a demand for light bulbs. And you see we have here different parameters like the price for the light bulb. So B is the price for light bulbs. But then we have also the price of electricity. So what is electricity to a light bulb? Well, that would be a complement. So price is of electricity. So electricity, that is a complement, a related good. Complement. And then we have the price of candles. What is a candle to a light bulb? Well, that is a substitute. And then we have income. And we assume that light bulbs are normal goods. So that is income. And what's important is also that it's a normal good. Okay. So now what we need to do is we need to identify the correct sign. So we have, so the way we can think of it is we have our demand function for light bulbs. But you see, it's actually written here, we have on the right hand, of the left hand side, Q. So this is a real demand function, not the inverse demand function. And so we have a demand function like this, however. But what do we know? So if the price for light bulbs goes up, so then on the demand function, if the price goes up, we see that quantity demanded goes down. So that is the inverse relationship between quantity demanded and the price. So the first sign here, that must be a negative sign. Because if the light bulb becomes more expensive, quantity demanded will go down. So that's an inverse relationship. Likewise, when the light bulb becomes cheaper, quantity demanded goes up. Okay, but now what about electricity? So electricity is a complement. So how do you react when it comes to very, very high electricity prices? Assume electricity prices go up by a lot. So if the price of electricity goes up by a lot, then what happens to the demand of light bulbs? Well, and obviously you will demand now less light bulbs. So the demand for light bulbs goes down, which is technically a left shift of the demand function for light bulbs. Again, we have an inverse relationship. When the price of electricity goes up, then you are more careful with using light bulbs, so the demand for light bulbs goes down. Or the other way around, if the price for electricity went down and becomes really cheap, well, then you will probably have more light bulbs around your house. But anyhow, so this is an inverse relationship, and we captured inverse relationship by a negative sign. Okay, so now the next one is the price of candles. So the candle is a substitute, and if the price of a candle, let's say, goes up, so now if the price of a candle goes up, that means you will replace at home all your candles maybe by light bulbs. So that means that the demand for light bulbs also goes up. So up, up, that's a positive relationship. So this sign has to be positive. And likewise, if the price for a candle went down, it becomes very cheap, well then you put up more candles in your home, which means that the demand for light bulbs goes down. And the last indicator is income. So, and we know if income increases and it is a normal good, not an inferior good, then we demand more of it. So let's say if you have a higher income, maybe you have a bigger house, and then you will have a nicer or a more abundant Christmas decoration with more light bulbs. And so the idea is if income goes up, demand for light bulbs goes up too, because it is a normal good. So that is positive as well. Okay, so now we have done this one here, and now we have two scenarios. Now, what does our demand function look like if the price of electricity is 2? Okay, if the price of electricity is 2, we put in here a 2. And the price of a candle is 1. Okay, so that is 1. And the income is 1,000. So then how can we write our demand function? Maybe I just put it here. So then our demand function is 6. Okay, so those are parameters that are given. They are, you don't have to worry about those. They capture things like elasticities and responsiveness to prices, but that's not so important for now. So then we have 6 minus 2 price of bulb. So here we have basically the price of the bulb minus 2 times 2, so minus 4, plus 2 times 1, so plus 2, plus 0.004 times 1,000, that is plus 4. Okay, so now we can collect terms, and our demand function becomes 6 minus 4 is 2, plus 2 is 4, plus 4 is 8. Okay, so when we collect terms, we get 6, 2, 4, 8, 8 minus 2 times PB. So that is our demand function. If we want to rearrange terms into the inverse demand function, we can put the price on the left side of the equation, and then we get 2 PB equals 8 minus Q, and then we have to divide both sides by 2, and then we get the inverse demand function, which is 4 minus 1/2 Q. Okay, so that would be our demand function, and specifically the first one. So this is I, and then we have a second one here. What happens if income doubles? Well, what happens if income doubles? We already know that if income doubles, what happens is that the demand function shifts to the right. Okay, so let's see what we get now. What we need to do is, instead of having 1,000, we have 2,000. So let's replace the 1,000 by 2,000. And now I do it here on this side. So then our demand function becomes QD equals, still this is all the same, 6 minus 2 PB minus 4, that hasn't changed, plus 2, 2 times 1, plus 2. But now, instead of 0.04 times 1000, we have 0.004 times 2000, so that is 8, so plus 8. Okay, so now let's collect terms again. 6 minus 4 is 2, plus 2 is 4, plus 8 is 12, so now we get 12 minus 2 times PB. Okay, so that would be the second. Actually, I put it here, so this is I, and this is... Okay, so this is now the demand function when income is 2000. Let's rearrange that again to the inverse demand function because we have to draw it. So the inverse demand function becomes then, so let's say first we have 2 PB, and then we get 12 minus Q, and then we divide both sides by 2, and then our final inverse demand function when income is 2000 is now 6 minus 1/2 QD. Okay, so let's maybe put that and highlight that, because those are the ones that we draw. So this is the inverse demand function for the income of 1000. And you see the intercept is 4, but they have the same slope. When the income is 2000, what happened is that the intercept went up, but they have the same slope. So you can already see how that leads to a shift in the demand. Okay, so those are the two that we need to draw. Okay, so we are supposed to draw them here. Okay, so we said one function is, let's insert the shape. So the first one was 4 minus 1/2. So that means the intercept was 4, the slope is 1/2, which means it will intersect twice as far as the intercept. Okay, so that is the first. And I'll just give that, I'll do the first one in maybe blue. And make it a little bit bigger. Okay. And the second one was 6 minus 1/2, and you see, because the slope is the same, the second one is just to shift technically up, but you know, you can also shift it this way and then extend the line. But the second demand function when the income is 2000 is now, and I'll make that maybe red. Okay, so blue is the scenario 1, red is the scenario 2. Okay, so now let's move to the quantity supplied function. So we have the supply function of light bulbs, and you can see, let me switch to, so we have first here the price of the light bulb. So what happens to the supply if you can get a higher price, of course, then the quantity supplied will increase. So the first sign is here a plus. So that captures the law of supply, which means that higher prices translate into a greater quantity supplied. Okay, so W, that is the wage rate that the workers get. So that is a cost factor. So if, let's say, the unions have successfully agreed or negotiated a higher wage rate, that means the production costs become more expensive, and we know when the production becomes more expensive, the supply curve shifts to the left. So when costs go up, then the supply goes down, so that must be a negative sign. So when wages go up, then supply goes down. And again, if you want to draw it, imagine just again how we illustrated that earlier. We have a supply function which is upward sloping, but when things become more expensive, we say, well, then the supply function shifts to the left, or it shifts up. It's the same thing, because the firms are rolling over those higher costs. Okay, and T is the price of tungsten, so that is another input factor which goes into a light bulb. So that is the same logic. If the price of tungsten becomes more expensive, well, then the light bulb becomes more expensive, and the firms try to roll over those higher costs to you. And so it either shifts up, but an upward shift is the same as a leftward shift, because at the given budget that the firm has, if things become more expensive, well, then they can produce less. But it is also a negative sign. Okay, so now we have here again two scenarios, and I'll put again the first scenario here. Okay, so first the price of the wage is 5 and the price of tungsten is 1. Okay, so here, so if this is 5 and this is 1, so then what do we get? Then our supply function is 1 PB, I just forget about that 1, PB minus 0.5 minus, because 5, it's actually minus 5 times 0.1 is 0.5, and then minus 0.5 times 1, that's another minus 0.5. So that supply function becomes minus 1. That's a supply function, but again, we prefer to write it as the inverse supply function. So let's put the PB to the left side of the equation, and then all we need to do is, just put the 1 to the other side. And then we get 1 plus QS. Okay, so this is now the supply function for the first scenario, which is the blue one when we draw it. Okay, so now let's move to the second one. If the wage is 10, so the wage doubles. Okay, I put it here, so this is scenario 2. So now the wage doubles, so now we have QS. Okay, so let's quickly erase those numbers here. And so everything becomes more expensive. Okay, so now the new wage is 10, and the price of tungsten goes up to 4. So now our supply function is still, we start with PB plus 10 times 0.1, that's 1, it's a minus, I'm sorry, well, that should be a minus here. Minus 1, because minus 0.1 times 10 is 1, and then minus 4 times 0.5, that's 2. And then of course that is the same as negative 3 plus PB. And if you want to rearrange that, so we have PB alone, then we can write PB is, now we put down the 3 on the other side, so then it is 3 plus QS. So that is our second one. Okay. Okay, so we have now scenario 1 plus QS, and scenario 2, where everything became more expensive, and you see that is like a leftward shift of the supply function. But let's add it to the graph. And so 1, the blue one we said starts at 1. So I just copy that quickly. It starts at 1. And it has a slope of 1. So it's like this. And the second one had an intercept at 3, but the same slope. So let's just copy this and then make it red. So it starts at 3 and has a slope of 1. Okay, so now we can see two scenarios. So the first scenario was this one here, so that is the first equilibrium. That was scenario I. And then the other one was scenario 2, the red one. So here, that is okay. Okay, so what happened is, what we can see is, in moving from the blue scenario to the red one, well, what happened is demand went up and supply went down. So the equilibrium quantity is always the same. So the equilibrium quantity in both scenarios is 2. But what happened is that the equilibrium price went up from 3 to 5. Because obviously what happened is that light bulbs became scarcer. It became once scarcer because there was more demand for it, but then it also became, the supply also got less because of the higher cost. So what happened is that the price as a result went up. Okay, so there's some other questions now. Find the equilibrium price in each of the following cases. Okay, the equilibrium price was once in the scenario I, the equilibrium price was 3, and then the equilibrium price went up to 5. So here we had the equilibrium price 3, and then the equilibrium price went up to 5. And the quantity was 2, and yeah, okay. And then determine graphically the intersection, and that is exactly what we did here. Okay, so I think this is actually one of my favorite exercises, because it really illustrates very nicely what causes shifts in demand and supply. Okay, so let's stop here, and in the next video we still can go over a couple of smaller multiple choice questions.